All right, guys. So it's finally time to talk about which workout routines that your functional groups will like. So I hope that you're excited because we're getting ready to learn our first infrared signal. And I typically start with the easiest one because this is the first one, maybe the easiest one to pick up and recognize. Will kind of give you an insight on how we're going to start treating all of the other functional groups throughout the entire series. Okay, so the very first one is called the alcohol functional group. Now, just a quick review of organic chemistry here, and maybe it's not a review. Maybe this is the first time you're seeing it. And if it is, then that's okay. We'll just pretend like it is a review. All right? So the alcohol functional group is an organic compound that we represent as an R. R, think of random. It can be any kind of random carbon chain or group that's out there. But off of that organic piece, we have an OH group. And this OH group is the presence of an alcohol. All right, so for instance, methanol is CH3OH. Ethanol is CH3CH2OH. Propanol is CH3CH2CH2OH, and isopropanol is CH3CHCH3 with an OH that hangs off in the middle. And that's what gives us our isomer or our iso group. All right, these are just a few alcohols. They're not many at all, right? So I've given you four examples of alcohol out of thousands that are present in today's laboratory environment. And um, what we will end up seeing is that all of these alcohol groups, no matter what they are, will actually give us the same type of um, infrared signal. Okay, so what does that signal look like? All right, well, I always like to start with a picture first, and then we'll talk about specifics a little bit later on after we feel comfortable with the shape of the peak. All right, so with every single alcohol group that you analyze on an infrared spectrometer, you will always see a very common shape, and it happens in the very beginning of the infrared. All right. And the shape that we will see is a huge big dip that comes down in the very beginning, and it will come back up and maybe touch the baseline or up here at 100% transmittance. That is the signal that we want to look for when a alcohol is present. Now, we're going to have to go through and we're going to have to talk about where this happens. And in the previous video, if you remember, I told you that this band can shift. And the reason is because look at all of these different choices here. An OH group is on one carbon, an OH group is on two carbons, an OH is on three, and OH is kind of in the middle here between two others. So this will never be an exact number. It's always a range of where we would see this shape take place. One of the things that I want to maybe bring to your attention is the description of the peak itself. And we call this a very strong signal. And the reason that we call this a strong signal is up here is 100% transmittance. That means the light goes through the sample and the sample has nothing to do with that workout routine. And then down here is 0% transmittance. And that means that all of the light is getting absorbed and nothing is going through and hitting the detector at all. So this is a very strong band, meaning that this band almost goes to the very bottom of the infrared spectrum and then back up. Because remember, this is percent T and this is wave number down here at the bottom per centimeter. And we start at 4,000 and we go to 600. All right, so a very strong band, meaning very deep. Another way that we can describe this band is we call it very broad. And broad basically is how wide that peak is. So it's a very broad peak and it's a very strong peak. Now, there's a number that this happens every single time. And this number is an important number for you to memorize because it's probably going to show up on a test. And the alcohol group will always show up in the range of 3650 to 3200. And if you look in this range, that's kind of where I've drawn that peak. 3650 to 3200. All right, and these are wave numbers, right? Centimeter per -1, wave number. So every single alcohol that I get to analyze on an infrared, no matter what type of alcohol it is, if it has an OH group, that OH group will show up in that particular region, in that particular shape, most of the time. And of course, there's always exceptions. So in the PowerPoint presentation that you'll eventually get a hold of, you will see a grouping of alcohol functional groups in that PowerPoint presentation. And the very first one that I want to look at is this one, which is methanol. All right, this is the actual infrared that has been pulled from the spectral database system. And if we look at the infrared, I might not know anything at all what these other peaks are coming from, and it doesn't matter at this point because we've not talked about them. But the one that I have talked about is this very strong peak and is this very broad peak that happens in the very beginning of the infrared. And that huge big dip is the presence of an OH group. So I might not know that this is methanol, but I do know that this is a alcohol functional group that's on the compound. And that's what we're after at this particular moment. That's it. What functional group is present? So there is my strong broad dip in the infrared and it comes right back up, and that is the positive signal for a alcohol functional group. Don't know it's methanol, but I at least know there's an OH group on it. Here's a different one, and this is ethanol, the good alcohol that you like to drink maybe. So the shape again in the very beginning, 36 to 3200, that's where this broad peak is at, and that's where this very strong peak is at. So that dip is the presence of a OH group. Don't know it's ethanol, but I know that it's an OH at least. Here's another example of an alcohol. This is propanol, 3-carbon chain with an OH group. I don't know that it's propanol, but I do know that there's an OH group on it because here between 36 to 3200, I see a very broad peak and I see a very strong peak. So that is the presence of the OH group. And finally, we'll do one more, and this is benzyl alcohol. And benzyl alcohol, it's not a straight chain carbon. It doesn't need to be. I picked this one to tell you that, hey, the rest of the molecule, it doesn't matter. If you got an OH group, the OH will show up every single time. So all of this other crap that's on the infrared, we're not going to take a look at. But I'll at least know there's an OH group on it. And that OH group happens between 36 to 3200, and sure enough, there's a big dip. And this is a very low dip, and it's a very broad peak. So that is the presence of the alcohol group, and it's one of the easiest ones to pick out in an infrared. And quite honestly, when I give tests or when I give lab practicals and I give an OH group, I don't think there's hardly anyone that ever misses the OH group. That's the one that they always seem to respond the best to out of the whole onslaught of functional groups that will happen and come your way. Maybe it's the very first one that we talk about, or maybe it's just because it's the simplest and most predominant one when it is present on an infrared. So in the next video, we will talk about other functional groups, and we're getting ready to go into a family of functional groups known as the carbonyls. So buckle your seatbelts because carbonyl functional groups, there's quite a few of them, and they're all very similar. And they're not as easy to pick out as an OH group is. Now, to me, I automatically see them, but I've been doing it for years. So we will walk through just like we did with OH. We'll start with one functional group at a time, and we'll gradually do maybe one lecture video on that one functional group and talk about the infrared for that one signal, and then we'll continue to move on and on throughout the lecture series. So carbonyls are coming up. Take a break, go pee, go get some popcorn, and I'll see you in a few minutes.